we have olfactory indicators. olfactory indicators क्या होते हैं? olfactory का मतलब होता है स्मेल, ठीक है, स्मेल। तो इसमें एक आ जाता है वेनिला। वेनिला अगर एसिड होगी, ठीक है, वेनिला इट विल गिव फ्लेवर, स्मेल जो इसकी होती है ना, फ्लेवर और स्मेल इन एसिड मीडियम ओनली, एसिड मीडियम ओनली, ठीक है। देन यू हैव अनियन। अनियन हमारी आंखों में लगता है। अनियन हमारी आंखों में क्यों लगता है? क्योंकि इसमें एक एसिड है, वो हमारी आंखों में जाकर के आइज के वाटर के साथ रिएक्ट कर रही है, तो उसको हमें आइज में, ऑलराइट। सो अनियन दैट इज दिस विल ये भी टिपिकल स्मेल in acid medium only, acid medium only। इसको हम लोग कहते हैं olfactory indicators। Alright, welcome students. See, we have come to know the general properties of acids and bases. Acids are sour to taste, bases are bitter to taste. Acids will give H plus ions, bases will give OH minus ions in solution. Then we had also talked about that acids will conduct electricity. Alright, acids will conduct electricity. Bases will also conduct electricity. जरा सा इसको हम summarize कर दें. That is, let us summarize it by writing the proper general properties of acids and bases. Alright, acids and bases. So first, if we write the taste, then acids are sour to taste, bases are bitter to taste. Alright, touch, acids are corrosive, जिस भी मेटल पर गिरेगी उस मेटल को खा जाएगी, उसको कहते हैं corrosive. Alright, they will eat away the metals. Bases are soapy to touch, bases are soapy to touch. Alright, then acids, they ions कौन से देंगे? Acids will give ions in aqueous solution. Acids will give H plus ions or H3O plus ions in solution. H3O plus we call it as hydronium. Bases will give OH minus ions in solution. Then acids with, okay, let us write litmus, action of litmus. Litmus, blue to yes, acids will turn blue litmus paper to red and bases will turn red litmus paper to blue, red litmus paper to blue. Then with metals, acids will react with all metals to give salt and hydrogen. Bases will react with only amphoteric metals. Amphoteric metals, that is amphoteric metals, for example zinc or aluminium. Zinc or aluminium, and they will react with amphoteric metal plus base. This will give salt plus hydrogen. Salt and hydrogen. then acids will react with oxides. ठीक है, acids reaction with oxide. So acids will react with metal oxide plus acid. This will give salt plus water. This will react with non-metal plus base, and this will give salt plus water. Alright, then after that, say neutralization reaction. We had already seen neutralization reaction, that is acids and bases, they react together to give salt and water. Alright, then there is one question, that is, say supposing if I have got 3 test tubes A, B and C. In, say supposing this is an acid, this is a base, and this is simply water. Now I have got only blue litmus paper. And I want to find out that which one is acid, which one is base, only with this blue litmus paper. I don't have red litmus paper. So with only blue litmus paper, how I will find out that which one is acid, which one is base, and which one is water? So what I will do is, first I will put this blue litmus paper in all the 3. So in A, what will happen? Blue litmus paper will turn red. B will show no action. Alright. C will also show no action. Alright. Now this paper has turned red. Now again, what I will do, that means A is, and this is an acid. Alright. Now again, what I will do is, now I have to judge from these 2 test tubes which one is base and which one is water. So what I will do, I will take this red litmus paper. Now the litmus paper has turned red, and this red litmus paper, I will add it to the test tube B, and this will turn blue. So I will judge that this is a base. Test tube C will show no reaction with any, whether it was blue litmus paper or it was red litmus paper, it will show no reaction. So that means C is water. Alright, C is water. Very fine. Alright, now we also know that the acids, they conduct electricity, bases also, they will conduct electricity. So let us perform a small activity to show that all hydrogen containing substances are not acids. Alright. So what we do is, we are taking water in a beaker. And in this we are keeping a cork to which 2 nails लगे हुए हैं, है ना? 2 nails are 2 nails are pricked in this cork. All right, and these nails, they are connected to a battery and then to a small bulb. All right, to a small bulb, and then with the help of switch they are connected like this. The circuit is completed. Now see, if this is distilled water, if this is distilled water, and if we are closing the circuit, then what we will find? That no bulb glows. Okay, no bulb glows, because distilled water, it does not contain any ions, no bulb glows. All right, then say supposing instead of distilled water, now if in this beaker we are keeping some alcohol. All right, we are keeping some alcohol, then also very faint, नहीं के बराबर, कितनी बार नहीं भी नजर आएगा. ठीक है, अगर ये बल्ब ज्यादा वोल्टेज का है तो कितनी बार नहीं भी नजर आएगा. वेरी फेंट बल्ब ग्लोस. ठीक है, और तीसरा, अगर हमने इसमें ग्लूकोज डाल दिया, ठीक है, देन ऑल्सो नो बल्ब ग्लोस. अगर हमने इसमें लाइम जूस डाल दिया, ठीक है, लाइम जूस डाल दिया, लाइम जूस डालेंगे तो बल्ब विल ग्लो ब्राइटली. दैट इज लाइम जूस. यू नो दैट इट कंटेन्स सिट्रिक एसिड. एसिड है तो ये H प्लस आयन देगा. H प्लस आयन्स आर कंडक्टर्स ऑफ इलेक्ट्रिसिटी. सो H प्लस आयन, ग्लूकोज का फॉर्मूला क्या होता है? ग्लूकोज इज C6H12O6. ठीक है, C6H12O6. अगर हम ग्लूकोज डाल देंगे या चीनी डाल देंगे तो चीनी भी क्या होती है? शुगर. शुगर को हम कहते हैं सुक्रोज. ठीक है, सुक्रोज. इसका फॉर्मूला होता है C12H22O11. तो देखो H इसमें भी है, H इसमें भी है, लेकिन यहाँ पे बल्ब ग्लो नहीं कर रहा, बिकॉज दिस H इज नॉट एसिडिक. This is not acidic, so bulb is not glowing. So that is all hydrogen containing substances, they are not acids. Only those are acids which will furnish H plus ions in the solution. Only those are acids. All right. Then one thing more I wanted to tell you, that is bases. May we learned about bases. We were learning about bases. So bases, we were talking about bases, that bases furnish OH minus ions in solution. So metal oxides which are soluble, ठीक है, metal oxides which are soluble are called alkali and they furnish OH minus ions. So supposing अगर हमने Na2O लिया तो इसको अगर हम वाटर में डालेंगे तो ये बनाएगा NaOH, और इसको हम, क्योंकि ये सोल्यूबल है, पानी में घुल गया, तो इसको हम कहते हैं एल्कली. ठीक है, तो जो बेस डिसॉल्व कर जाएगा पानी में उसको हम कहते हैं एल्कली. ठीक है, मेटल ऑक्साइड्स दे आर बेसिस, और जो बेस वाटर में डिसॉल्व कर जाएगा उसको हम लोग कहते हैं एल्कली. बहुत सही. Welcome students. So we have had a good introduction about what is acid and what is base. ठीक है, अब एसिड में भी हमने बात करी थी कि कुछ एसिड स्ट्रॉन्ग एसिड है, कुछ एसिड्स वीक एसिड है। स्ट्रॉन्ग एसिड क्या है? जो कि कंप्लीटली आयोनाइज होंगे, वीक एसिड कंप्लीटली आयोनाइज नहीं होंगे। ठीक है, अब इसमें कोई एक स्केल होना चाहिए कि कौन सी एसिड कितनी स्ट्रॉन्ग है ना, कौन सी एसिड कितनी स्ट्रॉन्ग है। तो इसके लिए सोरेनसन एक साइंटिस्ट थे, उन्होंने एक स्केल दी जिसको हम कहते हैं पीएच। यहाँ पर पी जो है छोटा लिखा जाता है, एच कैपिटल लिखा जाता है। इसका फुल फॉर्म क्या हो गया? इसको हम लोग कहते हैं पोटेंस। दिस इज जेड, पोटेंस हाइड्रोजन। पोटेंस हाइड्रोजन मतलब हाइड्रोजन की स्ट्रेंथ कितनी है, हाइड्रोजन की स्ट्रेंथ कितनी है। ठीक है, इसको हम डिफाइन कैसे करेंगे? दैट इज, दिस इज पीएच इज डिफाइंड एज द नेगेटिव power of 10, which denotes the concentration of H plus ions. For example, अगर हम कहें कि concentration of H plus ions is 10 raised to the power minus 2, तो pH कितना हो गया? pH is equal to 2. Alright, 10 raised to the power minus 2, तो pH is equal to 2. ठीक है, अब अगर हमने कहा कि concentration of H plus ions concentration of H plus ions is 10 raised to the power minus 2, तो pH is equal to 2. Alright, now अगर न्यूट्रल pH स्केल देखो जरा, pH स्केल क्या होगी? Let us write pH scale. Alright, तो pH स्केल अगर हम ड्रॉ करेंगे तो pH स्केल कहाँ से होती है? ये होती है 0 से लेकर के 14 तक। ठीक है, और बीच में इसका आ गया 7, तो 7 pH को हम लोग कहते हैं न्यूट्रल pH। ठीक है, तो अगर डिस्टिल्ड वाटर होगा तो डिस्टिल्ड वाटर का pH क्या होगा? 7। डिस्टिल्ड वाटर का pH होगा 7, और अगर 7 से लेकर के 0 के बीच में है pH तो इसको हम कहेंगे एसिडिक, और 7 से ज्यादा है तो ये हो जाता है बेसिक। ठीक है, ये हो जाता है एसिडिक सॉल्यूशन, और ये हो जाता है 7 से ऊपर 14 तक होगा तो इसको ये हो जाता है बेसिक। ऑलराइट, ये हो जाता है बेसिक। ऑलराइट, सो दैट इज कुछ कॉमन चीजों का हम देखें पीएच का इन आवर एवरीडे लाइफ में कैसे फंक्शन है। ठीक है, पीएच इन आवर एवरीडे लाइफ में कैसे कैसे है। सॉइल का पीएच क्या होना चाहिए? न्यूट्रल होना चाहिए, शुड बी अराउंड 7। इफ द पीएच is less than 7, that means soil is acidic। ऑलराइट, हमने बात की कि 7 से नीचे पीएच होगा तो एसिडिक होगा। सॉइल इज एसिडिक, देयरफॉर हमें बेसिक चीज है, देयरफॉर कैल्शियम ऑक्साइड और calcium carbonate or calcium hydroxide और such things, magnesium hydroxide, इस टाइप की चीजें हमें डालनी चाहिए इसमें, सॉइल में should be added, should be added, alright. और अगर इसमें if the pH is greater than 7, that means soil is basic, तो हमें एसिडिक चीजें, therefore acidic substances such as manure should be added, manure should be added, alright. So this is also again an important question कि सॉइल का pH अगर 7 से नीचे है तो हमें बेसिक चीजें सच एज लाइम, स्लेट लाइम, ये सब चीजें हमें इसमें ऐड करनी चाहिए. और अगर pH 7 से ज्यादा है सॉइल का तो हमें उसमें मेन्योर ऐड करना चाहिए. मेन्योर में कार्बोनिक एसिड होती है तो मेन्योर हमें ऐड करना चाहिए इसमें. और अब सेकंड चीज देखें, सेकंड देखें, दैट इज pH ऑफ स्टमक. हमारे स्टमक में एसिड होती है HCl, ऑलराइट. स्टमक contains acid HCl. Therefore, if the concentration of HCl is high, then concentration of HCl is high, then there is irritation in stomach. इस कंडीशन को हम लोग क्या कहते हैं? एसिडिटी. दिस इज कॉल्ड एसिडिटी. और इसको रेमेडी, इसके लिए क्या करेंगे हम? इसकी रेमेडी क्या करेंगे? पेशेंट इज गिवन weak bases such as magnesium hydroxide, इसको हम लोग कहते हैं मिल्क ऑफ मैग्नीशिया. और इस दवाई का नाम क्या है? इसको हम कहते हैं एंट एसिड. इसको हम लोग कहते हैं एंट एसिड, एंट एसिड. Alright. So students, we were discussing about pH, role of pH in our everyday life. ठीक है. अब थर्ड डिस्कस करते हैं. थर्ड इज टूथ डिके. टूथ डिके ये बड़ी प्रॉब्लम है, टूथ डिके, है ना. सो टूथ डिके, our tooth is made up of enamel. और ये enamel क्या है? Enamel is calcium phosphate. Enamel is calcium phosphate. ठीक है. Now the food what we eat, है ना? The food what we eat is acted upon by bacteria which releases acids, and this acid reacts with the enamel of tooth. This acid reacts with the enamel of tooth and causes tooth decay. Causes tooth decay. Alright. Tooth is made up of enamel, calcium phosphate, food what we eat. This reacts with the this is acted upon by the bacteria. This bacteria will release acids and this acids react with the enamel of the tooth and so it causes the tooth decay. अब इसको कैसे prevent करते हैं, है ना? So that is toothpaste. कहते हैं ना toothpaste में नमक है. So toothpastes contain some basic salts. Basic salts which neutralize this acid. Which neutralizes this acid. Alright. So this is how tooth decay is prevented. Now let us see the fourth application, that is alright. Now insects sting. We have some plants also and we have some insects also. Alright. So when the insects sting, then when the insects sting, they release an acid which is called formic acid. Alright. When the insect stings, it releases an acid called formic acid. क्या हुआ? मधुमक्खी काट गई, कोई रेड चींटी काट गई. So this releases a formic acid. तो ये formic acid, अब acid है तो ये हमारे स्किन को corrode करेगी तो we will feel itching on it. Alright, we feel itching on it. So अगर इस पे और जब ये बिकॉज इसने एसिड रिलीज की तो ये खुद को भी उसको इरिटेट करती है. अगर वो ज्यादा देर उसके ऊपर बैठ गई तो वो खुद भी मर जाती है. ऑलराइट. सो दैट इज व्हेन द इंसेक्ट स्टिंग्स इट रिलीजेस एन एसिड. दिस इज कॉल्ड फॉर्मिक एसिड. फॉर एग्जांपल हनी बी स्टिंग और red ants sting. Alright. So all these, they contain an acid which is known as formic acid. There is a plant called Urtica dioica. Urtica dioica. Alright. This plant also, causes itching. So it is due to because when we touch this plant, this releases an acid, that is formic acid is released, and this plant causes itching in our hands. Alright. So this was about the pH in our daily lives. Salt. Alright, welcome students. Now we have learned about acids and bases. Alright. Now let us learn about salts. Salts को हम बनाते कैसे हैं? That is, we already learned that when acids they react with bases, they produce salt and water. they produce salt and water. Alright, so let us learn about different salts. कैसे salts हैं. ठीक है, so we have classification of salts. Classification of salts. Alright, so first part, that is we will write neutral salts. कैसे बनेंगे neutral salts? Neutral salts, that is strong acid. When strong acid is reacted with strong base, we have learned that we have strong acids and weak acids. So strong acid such as HCl, this reacts with a strong base such as NaOH. So this will react and this will give NaCl plus H2O. So this is a neutral salt. Alright. Then similarly we have acidic salts. Acidic salts, that is salt of strong acid and weak base. Strong acid and weak base. So strong acid we can take HCl and weak base we can take ammonium hydroxide. Alright. So when HCl will react with ammonium hydroxide, the salt produced will be ammonium chloride. The salt produced will be ammonium chloride. Ammonium chloride plus water. Now this ammonium chloride, this will show an acidic pH, that is its pH will be less than 7. Its pH will be less than 7. Alright. So similarly, we have acidic salts and we have basic salts also. So we can write the third category, that is basic salts. What are basic salts? That is salts from strong base and weak acids. Strong base and weak acids. So strong base we can say NaOH and weak acid we can say acetic acid, that is CH3COOH. CH3COOH. So this forms the salt, that is CH3COONA plus H2O. Plus H2O. So this is a basic salt. This is a basic salt since it is formed from a strong base, and this is a weak acid, so we call it as a basic salt. Alright, now we have to learn about different salts. So first of all, let us learn about different salts. So first salt what we will be learning, that is common salt. Common salt. What is the formula of common salt? That is NaCl. NaCl. We call it as common salt, NaCl. Where it is found? It is found in naturally it is found in seawater. Naturally it is found in seawater, and we also have rock salts also. Rock salt also of it. So we call it as, this is NaCl. Now from seawater, how it is extracted from seawater? That is, this seawater, this is taken in shallow tanks. Alright, this is taken in shallow tanks. Seawater is taken in shallow tanks, and this is kept in sun. This is allowed to evaporate, and then all the water will evaporate and salt will remain back. So this is a natural process of preparing NaCl from seawater. This is known as from natural process we can prepare the common salt. Alright. Now second salt what you have to learn is that is caustic soda. Caustic soda. So all these salts, now what you will be learning, they are all prepared from NaCl only. Caustic soda. Caustic soda is NaOH. How is caustic soda prepared? This is prepared by electrolysis of aqueous NaOH. Electrolysis of aqueous NaOH. I'm sorry. Aqueous preparation of NaOH. Alright. NaOH is prepared by electrolysis of aqueous NaCl solution. Aqueous NaCl solution. When you do electrolysis of NaCl solution, then you get what you will be getting. Electrolysis, how electrolysis is done. Say supposing we are keeping NaCl solution over here and we are keeping two electrodes. So this is say positive and this is negative. So what will happen? This NaCl, this will break up into Na plus ion and Cl minus ion. This Na plus will go to the negative electrode which is known as cathode. At cathode, Na plus will go and this will take one electron and this will become sodium metal. Alright, sodium metal. Now this sodium metal, we have water. Since we are taking aqueous solution, we have water in the solution. So this will react and this will give NaOH in the solution. It will react and this will give NaOH in the solution near the cathode. Similarly, the Cl minus ions, they will go towards the, alright, this will give NaOH. Now we have this OH has come from the water, so that is H plus has remained. So this H plus, what it will do, that is 2H plus, H and H, they will combine. H plus, they will combine, they will take up 2 electrons and this will give H2 at the cathode. This will give H2 at the cathode. This will give H2 at the cathode. Similarly, we have at the anode, what will happen? Cl minus ion will go at the anode and this will 2 Cl minus ions will become Cl2 and this will give out 2 electron. This 2 electron, they will be going to the cathode. So ultimately what we can write is that electrolysis of NaCl equals, this gives us 3 products. That is, it will give us NaOH. NaOH, this is obtained near cathode solution, and we get H2 from it. This is at the cathode, and Cl2 at the anode. This is at the cathode. This question is a very common question, that is to name the products obtained during the electrolysis of aqueous NaCl solution. So during the aqueous NaCl solution, when you are doing electrolysis of it, you will be getting NaOH, you will be getting hydrogen at the cathode and Cl2 at the anode. Alright. Alright. Now this caustic soda, where you will be using caustic soda? Uses of caustic soda. Caustic soda, where you will be using? Caustic soda, this is used in soaps and detergents industry. Soaps and detergent industry. Then it is also used in paper and pulp industry. Paper and pulp industry. And it is also used in chemical laboratories as a reagent. This is a very important reagent, so we are using it in chemical laboratories also. This is main uses I have written, that is paper and pulp industry, soap and detergent industries. We are using caustic soda. Alright, now this was about caustic soda. Then let us write the second salt, that is bleaching powder. Bleaching powder. So this is also again obtained from NaCl only. From NaCl, what all we are obtaining? We will obtain caustic soda. Caustic soda, that is NaOH. From NaCl, again we will be obtaining bleaching powder. Bleaching powder is CaOCl2. This is known as bleaching powder. Then we will also obtain the baking soda, NaHCO3. This is also obtained from NaCl only. And we will also obtain the washing soda, that is Na2CO3, from NaCl only. Bleaching powder, that is CaOCl2. Chemical name is calcium hypochlorite. Hypochlorite. Calcium hypochlorite. Now how this is obtained from NaCl? Because this is calcium, this is sodium chloride. Now see, in the preparation of NaOH, you had seen that we had a byproduct when you did electrolysis of aqueous NaCl. You got three products, that is NaOH plus hydrogen plus chlorine. Alright, plus chlorine. Now this chlorine, what you get over here, this is passed in calcium oxide solution, that is calcium oxide का solution जब हम बनाएंगे, this will in water, this will form CaOH whole twice. Alright, this is known as quicklime and this is known as slaked lime. This is known as slaked lime, and this calcium hydroxide, when you pass chlorine in it, then this will form CaOCl2 and H2O, and this CaOCl2, this is only known as bleaching powder. This is known as bleaching powder. So bleaching powder, what it will be used for? What all uses we will be having for bleaching powder? Of course, to bleach what? To bleach the textiles, paper pulp, etc. This is used for bleaching. Then this is also used as disinfectant. This is also used as disinfectant. This is used in swimming pools, and this is simply sprinkled on the roadside, etc. This is used as a disinfectant. Alright, so this is bleaching powder. Alright, now let us learn about the third salt, that is sodium bicarbonate. We call it as baking soda. Baking soda or NaHCO3. NaHCO. Let us learn about the third salt, that is baking soda, NaHCO3. NaHCO3. Now this is also again formed from NaCl only. How this is formed from NaCl? What we will do, we will take the solution of NaCl, aqueous solution of NaCl. In this aqueous solution of NaCl, we will pass carbon dioxide. We will also pass ammonia gas in it. Alright, so since this is aqueous solution, I will write H2O over here. Now see what all products we will be getting. We will be getting from here, we will be getting NaHCO3 plus NH4Cl. NH4Cl. We see if the equation is balanced. We have 3 oxygen over here. We have 3 oxygen over here. 1 sodium, and how many hydrogen we have over here? 3 plus 2, 5, and over here 4 plus 1, 5 hydrogen we have over here. So the equation is also balanced. NaHCO3 and ammonium chloride we get, and this is called as baking soda. So baking soda, let us see baking soda. Uses of baking soda, as the name implies, this is used for baking breads and cakes. How this is used? In baking powder. Now what is baking powder exactly? Alright, baking powder, this contains baking soda plus tartaric acid. Mild acid, this is tartaric acid in the form of potassium tartrate. Alright, so this tartaric acid, when this baking soda, this acts means water is mixed to it, then this baking soda, this will react with the tartaric acid and carbon dioxide is released. Carbon dioxide is released, which will give lots of air spaces, and the breads and cakes, they will become fluffy. So baking powder, it is whenever you say baking soda, only baking soda, if you use only baking soda, then the cakes will not rise. It is only when baking soda is mixed with some acid, say supposing if it may be lime juice or any acid, then this will react as a, this will behave as a baking, this will behave as a baking powder. It will behave as a baking powder. Alright, now baking soda. Then after that we have the fourth salt, that is washing soda. Washing soda. Now washing soda, this is Na2CO3 10H2O. Alright, Na2CO3 10H2O. Now how this is formed, Na2CO3, this is known as Solvay's process. This is known as Solvay's process. NaOH formation, this was known as chlor-alkali process. Chlor-alkali process. Why this is known as chlor-alkali process? Preparation of NaOH. Preparation of NaOH. Why this is known as chlor-alkali process? Because in this process you have seen that chlorine is also produced, the alkali NaOH is produced, and of course hydrogen is also produced. So we call it as chlor-alkali process. Alright, now let us see